Today's lesson is on segment addition. Now, segment addition is how we unite the two concepts that we've been learning, geometry and algebra. So today we're going to bring in some of the skills that we learned first semester, like solving for x, plugging x in to find a value. Those are all things that we're going to be talking about today. Okay. Mathematical definition of segment addition is that if you have 3 points, let's say A, B, and C, and they're all collinear, meaning again, they're on the same line, then we can consider those as line segments, right? So we have the space from A to B, the space from B to C, and then the space from A all the way to C. Those are 3 different line segments, okay? And what segment addition is saying is that A to B plus B to C is going to add up to be the total distance from A to C. Super easy to understand in theory, but let me just explain it as a practical real world thing, okay? Let's say that I had to walk 5 miles, okay? So from A to C, that's a 5-mile walk, but I get tired, so I only walk a little bit of it. So I'm going to walk from A to B, and that's 2 miles. Then I stop at B, and I'm going to take a break. Okay. Now, just based off what you know about how things add up, how many more miles do I have to walk to get to C? 3. Very good. Because I know that the whole walk from A to C is 5 miles. And if I've already walked 2, that means the rest of the walk is 3 miles. Okay. That's all segment addition is saying, that these 2 little pieces up here have to add up to the whole thing, okay? It wouldn't make sense if A to B was 2 miles and B to C was 3 miles and A to C was 10 miles. That doesn't make any sense, right? Those numbers don't add up. So segment addition is just saying that the 2 little pieces have to add up to the big piece here at the bottom, okay? So what we're going to do today is we're going to go through 5 examples of segment addition. We're going to start off super easy, and then we're going to get progressively more difficult, and then we're going to start throwing in things like variables where we have to solve for x. Okay, so let's jump off and get real into geometry today, but we're going to start super simple. So here's example number 1. Okay, find the total measure of the segment xz if segment XY is 17 and segment YZ is 25. Now with geometry, it's very important that when you have a picture, you interact with the picture. And this is the difficult thing about this school year. In a normal school year, I'd be able to give you paper, you'd have the pictures in front of you, you'd be able to write on them. But because everything is on computer, you're gonna have to write down the pictures yourself. So I would always recommend having a piece of paper so that you can write things down and you can annotate, especially in geometry. It's very important for you to annotate. So if you don't have paper in front of you when you're doing the homework, I don't think that's a good idea, okay? Because you're going to want to draw these pictures. Okay, let's fill in what we know. It says right here from X to Y is 17. So I'm going to do that in red. So from X to Y, that is 17. Then it says from Y to Z, I'll do that in blue. Y to Z is 25. And we want to know what is the total distance up all the way across from X all the way to Z. Okay. Now, how are we going to figure that out? What do we need to do? Add. It's called segment addition, right? So we need to add together these 2 numbers. Again, this is exactly what we did right before this, okay? From X to Y is 17, from Y to Z is 25. So if I add those together, I'll get the whole distance from X to Z. So 17 plus 25 is going to give me 42. And that is the total space or length between X and Z. Okay, the measure of that line segment. Okay, kiddos at home, any questions on that first example? Okay, let's step it up a little bit. So example 2, we have 4 points. Okay. And so we're just going to read the situation and fill in what we know. Okay. It says AB equals 7. Okay. So AB is 7. DC is 5. And AC is 30. Now be careful. AC starts here and goes all the way here, and that's 30. And the question says, what is the length of the line segment BD? So what is this part in the middle from B to D? Okay, let's talk about how we figure that out. Okay, so if I know from A to B is 7 and D to C is 5, I can subtract those values away from 30, right? Because the whole thing is 30. So if I subtract 7 and I subtract 5, that will tell me what's left over from here to here in the middle. And that gives me 18. So if BD is 18, how do we check to make sure we calculated things correct? Add them all together and make sure they add back up to what? 30. 7 plus 18 is 25, plus 5 is 30. So we did it right. Okay. Super easy peasy. Now, when there's numbers, really easy. All you're doing is adding or subtracting. Okay. What we're going to do next is we're going to throw some algebra in there. So now, instead of there just being numbers associated with these lengths, we're actually going to throw in some variables. Okay. The important thing is nothing changes. In every single example, the small line segments add up to the larger line segment. Okay. Think about that ruler. If I broke a ruler into pieces, those pieces still add up to the whole ruler. Okay, so that's all we're doing. We're breaking something into pieces, adding them back up and seeing what they equal to. Okay, so example 3, this is going to be our first example where we're throwing in some algebra. Okay, the points A, B, and C are collinear. D should be on there too, sorry. So let's look at what we're given. AB is x minus 6. Okay, so A to B, I'll do this in red, is x minus 6. It then says BC, B to C is 2x minus 1. So B to C, 2x minus 1. If AC is 23, so A to C, that whole length is 23, what is the value of x? So it's the same thing we've been doing. The red piece plus the blue piece equals 23. Does that make sense? The two little pieces on the top add up to the 23. Can I get a little confirmation? Yes or no? Okay, so think that this is one long piece. It's 23, right? And I broke it into 2 pieces. If I add those 2 pieces up, they have to equal the 23. That's what I'm doing. Okay, now because we have some variables in here, we're going to have to make an equation. So let's add these things together. Okay, I have 1 red X and I have 2 blue X's. So how many X's altogether? I have 1 red X and 2 blue X's. So how many X's altogether? 3. Okay. Then I have -6 and -1. Okay. -6 and -1. So what does that make? Is it positive or negative?
Negative.
-7. Thank you. Okay, very good. Okay, now this is equal to what? 23, very good. Okay, and now we have a problem just like first semester. I got to solve this. So we have to go all the way back to our previous skills from first semester and work backwards. How do I get rid of -7? I add 7 to both sides. Very good. Okay. That goes away. 3 times x equals 30. This says 3 multiplied by x equals 30. How do you get rid of multiplication? Divide by 3 on both sides. And so x equals 10. And that's it. Okay. So the big thing with this problem is just remembering the little pieces have to add up to the whole way across. Okay. So you're adding up the 2 pieces on the top, the red piece and the blue piece, and they equal the whole length across. Okay. Any questions about that? Okay, let's move on. We're going to do another one just like this so that hopefully you get more comfortable and you can help me out a little more. Okay, now that you've seen it. Okay, example 4. Okay, so let's read through it. If AB is 4x plus 9. Okay, so I'm going to do that in red. So AB, that's from here to here, is 4x plus 9. And BC is 5x plus 2. So from here to here, that's 5x plus 2. And AC, so from A all the way to C, is 56. They want us to find 3 things. They want us to find X, they want us to find AB, and they want us to find BC. Okay. Okay. Now, this is why hopefully you can see in geometry, if you're not drawing the pictures out, it's going to be really hard to do this all in your head. And this is just our first lesson. So I really hope that when you guys go to do the homework tonight, you're thinking about drawing these pictures out so that you can interact with the picture. Okay, you can annotate onto the picture. Okay, so looking at what we have the red piece from A to B, we have the blue piece from B to C. Both of those things have to add up to what? When you add the red piece and the blue piece together, what do they have to equal to? 56. Okay, so let's add them together and set them equal to 56. So I have 4 red X's and I have 5 blue X's. So how many X's altogether? 9X. Now I have +9 on the red side and +2 on the blue side. So when I add 9 and 2, I get +11. Very good. And again, those things have to equal up to what? 56. Thank you, the kiddos in the text box who are responding in chat. I love hearing from you guys as well. Thank you so much. Okay, let's work backwards. So I have to get rid of +11. How do I do that? -11 from both sides. Okay, we got to keep it balanced. Okay, 9x comes down. 56 take away 11 is 45. And now this says 9 multiplied by x equals 45. How do I get rid of multiply? divide by 9 on both sides. Okay, so x equals, and what is 45 divided by 9? 5. Okay, so that's one of my answers. X is equal to 5. Now, if I know that x is equal to 5, how am I going to find AB? I'm going to replace x with the number 5. I'm literally going to go to the equation that's right here for AB, and I'm going to plug in 5. So 4 times 5 plus 9. Okay, 4 times 5 is 20 plus 9. That gives me 29. Okay, now I'm going to do the same thing for B to C. I'm going to plug in 5, and I'm going to add 2. 5 times 5 plus 2. 25 plus 2 is 27. Okay, now let's check. 29 plus 27 equals 56. So I know that I didn't make a mistake. Okay. Now, not every problem is going to have 3 steps at the end. Most of the problems are just going to say find x. Okay. But there are problems where you have to find x and then plug it back in so that you can actually solve for the length. Okay. Any questions about example number 4? Okay, we got one more example. Okay, last one, and this one, we're going to step it back a little bit. I want you to help me through this. Okay, so we're going to annotate our picture. You're going to help me set up the equation and solve. You've seen a couple examples now, so you guys should be able to do this. Okay, looking at our line segment, S to U. So we have ST, TU, and SU. Find the length of ST. That's very important. We are looking for ST. Okay. If ST and U are collinear, ST is 7x. So S to T is 7x. SU is 45. So we got to be careful. SU is from here all the way across. That's 45. And TU, so from here to here, is 5x minus 3. Okay. So I need you to help me set up this equation. Red plus blue equals the whole distance across. Okay. Red plus blue equals 45. That's how we set up our equation every single time. Okay. So let's count up our x's. I have 7x and 5x. How many x's is that? 12x. Very good. Again, thank you to kiddos in chat. Okay. I don't have any red numbers, but I have a blue minus 3, so I'm going to include that. And those things together equal 45. Okay. Now, how do I work backwards here? What do I do first? Add 3 to both sides. So 12x comes down. 45 plus 3 is 48. And then I'm going to divide by 12 on both sides. Does anyone know what 48 divided by 12 is? 4. Very good. Now, it says x equals 4, but is that what the question is asking me? No. The question is asking, what is the length of ST? So what do I have to do with the 4? Very good. I got to plug it in right here. So ST is 7 times 4, and that gives me 28. And that is my final answer, 28.